So let's talk about the naming, but now it's getting confusing because we're going to talk about the naming for molecular compound. Well, before I talk about this, now I hope you're already clear why we call those ionic compounds, why we call those a molecular compound. Ionic compound is made by the cations and anions. They are having charge. So generally, if you're looking at the ionic compound, we're not for the ionic. That's just a ionic compound is a cation plus anion, which means those are charged ions. So that's why the cations and anions combine together. As long as we know the charge, we can balance this compound. So that's why when you see an ionic compound, you always see an empirical formula, which means the ratio always is a simplicity ratio, right? We always see is an empirical formula. So this is an empirical formula, but also is the formula for itself. Okay, yeah. But if we talk about those in detail, sodium chloride is not just a single sodium ion combined with a single chloride ion combined together. No, not exactly. Those are actually is in a matrix. If you talk about a matrix inside of inside of the compound, actually it's just something like this. Okay, so we have one of the sodium ion, one chloride ion, one sodium ion, one chloride, and chloride, sodium, chloride, sodium. So you see, then it's just like this. So if you're looking at here, everywhere the sodium and chloride is just 1-to-1 ratio. So that's why they are just showing the ratio. The formula of this is just showing the ratio between the cation and anion. It's just one versus another one. Okay, 1 and 1. So this is what happened for the ionic compound. Okay, just to let you know, the ionic compound, those compounds actually we have multiple cations and anions combined together, but the ratio is always 1-to-1 in the sodium chloride in this case. So that's why this is ionic. But molecular compound is completely different. Molecular compound is those compound is made by atom plus atoms. So it's just atom plus atom. One of the atom combined with another atom, then they are having a covalent bond. Okay, so the molecule. So that's why when we talk about the molecular compound, we talk about they are making a molecules, because those are several atoms combined together making a molecule. For example, H2O, right? Hydrogen is non-metal, oxygen is non-metal. So this is generally, if you're looking at the shape, it's just a big oxygen molecules and combined with 2 small hydrogen molecules, something like that. Okay, so that's why we call this a molecule, because it's this single molecule is made by 1 oxygen and 2 hydrogen atoms. Okay, so this is a molecules, and then they are going to, if we have 2 of the water molecule, it's just 2 of the water molecules, and those 2 water molecules actually is not exactly bond together. Okay, they are free then, they are free. But if you're looking at the ionic compound, you see those are all binding all together. Okay, although the ratio is sodium chloride, the ratio is 1-to-1, but actually we have a multiple cations and multiple anions combined together. Okay, so that's why we never see ionic compound a molecule, because actually it's not a molecule. Okay, they just combine them together. So we only call molecular compounds a molecule. Okay, are you clear? Okay, yeah. So that is why if you're talking about a molecular compound, the how many numbers shows under the hydrogen or oxygen is exactly how many numbers of the atoms inside of the molecule, inside of molecules. Okay, yeah. So for example, everyone probably know this. You know this H2O2 peroxide, yeah, hydrogen peroxide. Hydrogen peroxide, you're not going to make the ratio, make the formula as HO. This is not right because this is a molecular compound. Two atoms, hydrogen and two atoms oxygen is exactly shows in the molecule. Okay, yeah. So generally it's two big oxygens and two small hydrogen shows up there. So this is what happened that shows in the molecule. Okay, if you're divided by 2, then become 1 hydrogen and 1 oxygen, then we're not going to have this kind of molecules. So are you with me? Okay, when you write a molecular compound, you're not going to write a simplicity ratio, which is the empirical formula. Okay, yeah, the empirical formula may or may not different from their molecular formula. Are you clear? Okay, yeah. Well, if you're talking about CO2, well, CO2, then this guy is the molecular formula and also is a molecular formula. It's just a 1 carbon and the 2 of the 1 carbon and the 2 of the oxygen combined together. So this is carbon, those are 2 oxygens. So making a molecule like this. Okay, yeah. So this is what happened. So that is why the numbers, the subscript for each of the molecules means something. Okay, means something. So that is why when we do the naming, the molecular compound naming is quite different from the ionic compound naming, because we need to specify how many numbers of those atoms in there. Okay, how many numbers of atoms in there. So that's why the naming is different. But right now, we just talk about the 2 atoms combined together. The molecule that with 2 atoms. Okay, the molecule with 2 different atoms. So this is what we call a biatomic molecule. So naming for biatomic molecules. Which means just by two of the molecules. One example is just water or CO2 or CO, NO2, NO, N2O, N2O4. So those are all the molecular compounds, and with 2 atoms, 2 different kind of atoms are there. So when they name this, it's a little bit, it's different from the ionic compound. How many numbers shows in the molecule means something. Okay, yeah. So for example, NO2 is different from N2O4. Those are 2 different molecules. So when you give it a name, it's also different. Okay, so first let's talk about name, how to name it. Usually we're talking about the first atom and the second atom. For the first atom, this is the first and this is the second. Okay, so this is second, this is the first. So first atom, when we give it a name, it just talk about the name of these elements. Okay, just give it a name of the elements plus a prefix. Plus a prefix. This prefix including the following. Okay, so if it's a 1, then that's a mono. If it's 2, that's a bi. 3, that's a tri. 4 is in the 4.
It's tetra, isn't it?
It's a tetra. Yes.
And then it's penta for 5. I have no idea what 6 is. So. I have no
What is
idea.
the hexa, right?
Oh, it's
a
yeah,
hexagon, right?
it should be.
So
10.
6 is a hexa. 7 is a hepta. 8
Octa, probably.
octa.
I have no idea what 9 is.
9 is a nona.
Okay.
10 is a deca. Okay, so to be honest, I'm not sure where this is come from. Is this a Latin?
I think it's Latin.
Is it Latin?
But I'm not sure. I'm not sure at all. That sounds.
Yeah.
It sounds like. Latin.
Probably is from Latin. Yeah, but I'm not sure. But usually chemistry, this is a very common prefix in chemistry. Okay, yeah, they have those are the prefix of there. Okay, so the first name you're going to have a prefix and the name of the elements. There's an exception, except for 1. Yeah.
Force. Yeah,
Only for 1 atom, but this is only for first atoms. Okay, second atom you always write the prefix. Okay, you always write the second atom, you always write the prefix. So the second atom is the name of the elements, and then you need to get rid of ending plus IDE. Okay, remember IDE again. Okay, we talk about the IDE. What happens when we have an IDE? When you have only just a single ani, this has IDE. This one also. When you only have a single atoms for the second atom, then that's adding IDE and then plus prefix. Plus prefix. Prefix is follow the same rule. Okay, so right now in this one doesn't matter how many numbers of atoms, they always write the prefix, even we only have 1 atoms. Okay, so let's just go to looking at those. Okay, so what do you think for the first one? What is that called? Should be called dihydrogen monoxide, but we never call this.
No.
Okay, it's called water. Okay, you know it. Okay, yeah. So this is a water and this is a trap. Okay, don't give me an option, dihydrogen monoxide. Okay, so then maybe in the ad they tell you, okay, so if you have some makeup, it's containing dihydrogen monoxide in there. Well, looks like very fancy, okay, but actually just water. Okay, yeah. So this one is called carbon monoxide. So you know, and follow the rule. Carbon, first one is a single atom, so don't add anything. Just the name of this element. So this is carbon. And then it's a something ide, right? So this is oxygen, so oxide. And then I only have 1 atom, so you put a mono in front. Okay, so the prefix generally shows how many numbers of those atoms. Okay, prefix shows how many numbers of the atom. So this is a monooxide. If there's an O in there, you I think you don't have to write 1, but I saw some people add 2 O's in between, but that's all totally fine. This one is a monodioxide. sorry, it's a carbon dioxide. Carbon dioxide, which means talk about two oxygens, right? And then this one is called nitrogen dioxide. This is a nitrogen dioxide. Okay, so based on the rule, go ahead to name the rest of the three.
Get it, girl.
I love them phone.
Definitely not Hefton.
You guys are
Sounds
such
like
nerds. Who likes, girl, you're talking about prefixes right now. I love, like, so that's such a cool prefix. You're such a nerd.
I said often.
Wait, those are such nerds.
The
Octonauts.
Like often, like.
Okay, so NO is called nitrogen monoxide. Nitrogen monoxide. And then this one is called a dinitrogen
Monoxide.
and the monoxide. Remember, we always write the numbers for the second one, monoxide. And this one is called a dinitrogen tetraoxide.
Oh, yeah.
And this one is called a dicarbon hectachloride. Last one is carbon tetrachloride.
I swear I've heard about
You heard this before, of course.
like cancer juice or something.
Tetraoxide. Do you know what is this?
Cancer.
Carbon tetrioxide.
He said.
This is a freon. This is a freon. Okay.
Oh, it's not what.
So carbon tetrioxide is a freon. Okay. Yeah. But usually the freon you see is a liquid, right?
Wait,
Yeah.
hydroxide?
But actually one, I think. Oh no, tetrachloride.
Yeah.
Yeah, tetrachloride.
Yeah.
Okay, so this is a freon, and usually, you see the freon is a liquid. That's because they experience very high pressure. But actually, freon is a really light gas. Okay, it's really light gas, and so also is what is that called? Is a green gas, greenhouse gas. Okay, yeah, it's much stronger than methane, which is a CH4. Okay, so. Yeah, it can absorb quite a lot of heat. Okay, for the freon. All right, so you see, this is a very important for numbers of the atoms shows in the molecules, right? Shows in the molecules. Very important. And then the different number, it give you the different molecules. Okay, yeah. So when we talk about now, looks like it's pretty straightforward and pretty easy, right? But it very confusing when I mix everything together. Okay, yeah. So I'm going to give you six naming, and then you can go ahead. Okay, you can go ahead to name it.
Yeah, but it's also.
Dr. Chow,
Hmm?
so before we knew all of this, CAO.
Oh, sorry, it's actually, this one is a die, not a buy. thing.
Right.
This is a two is a die. Yeah, it's a die.
What about bicarbonate?
Bicarbonate, this is just a common name, but actually it's not called a bicarbonate. It's a hydrogen carbonate.
Oh, okay.
Yeah.
So I have a question. So before we knew this rule, when we would like write CaO, like we would just put calcium oxide.
Yeah,
Mhm,
yes, that's what
mhm.
it is. It's tricky. That's
No,
what it is.
I know, but okay. I was wondering if there were, okay, well, never.
There's
mind.
no overlap rule between those three.
Never mind, I just.
Saying we thought it was for it before, and then you just flipped it on us.
I
So
was-
that's why when you do this, okay, you need to be clear. Okay, so that's why rule number one for naming is look at what kind of the molecule it is, what kind of those compound it is before you're doing the name. To recognize, we have a three different kind of naming, right? Ionic, compound, acid, and molecular. So you need to identify what kind of the compound it is before you're doing the naming, and then follow the rule of those compounds.
Right.
Okay, there is no overlap rule for those three. Okay, yeah. So each of those has a very different system. So that's why look at here. The first one is calcium, then is chloride. So this is metal plus non-metal. Obviously, is ionic. Then you follow the ionic. Then cation's name plus anion's name, and you don't have to specify the name, the numbers, right? Right. Remember, we just need to follow the charge as the cation and anion. The cation is calcium, anion is chloride. So this is just called calcium chloride.
Right. And that's why I was thinking.
Yeah, so that's why I'm saying naming will give you confusing because you don't know what is the rule. So first, you need to identify what kind of molecules it is. Then you're based on that doing. So there's a calcium chloride. And this is acid, right? So this is called a hydrochloric acid. I think there's a question shows up there, right?
I don't think there was one that asked.
No, not this one. Next one, calcium oxide, right? Is an ionic compound, metal plus non-metal. So this is a calcium oxide. And then this is a nitrogen chloride. So non-metal plus non-metal, then that's give you a molecular compound. So this is a dinitrogen dichloride. Okay. This one again, carbon, non-metal, chloride, non-metal. So this is a dicarbon dichloride. And then magnesium oxygen, this is metal plus non-metal, so this is ionic. So that's just a magnesium oxide. You see? Based on the different ionic compounds, you give it a different name. So that's why it will give you very confusing. And then, so that's why I didn't show this in the unit 1. Otherwise, it's gonna be very confusing in the naming parts. Okay, yeah. But this question will go to the next part. Okay, we'll go to the next part. Okay, so now I think we're going to done for the totally the unit one parts, okay? And then we're going to talk about some of the concept, which is the mole. I think most of people already know what is a mole, right? Yeah, the mole is a very big number. Okay, well, actually, mole is a unit. This is a unit, but this unit means a very big number. And this very big number is called the Avogadro's number. Avogadro's number is a 6.02 times 10 to the 23. Okay, 6.02 times 10 to the 23. You probably have no idea what is how big this number it is. I mean, this is a very big number, but then you probably have no sense. I gave you one of the example, two of the examples. You probably know it. Okay, so anyone has the lollipop? So yeah, you know what is the size? How big, how heavy the lollipop it is, right? Yeah. So yeah, so that's kind of like this a lollipop, right? I measured it's about like just a 5 grams, maybe a little bit heavier. Okay, yeah. So if we have a mole, 1 mole of the lollipop, okay, which is 6.02 times 10 to the 23rd of the lollipops. That's gonna be a lot. Okay, you know, you can you imagine it? Okay, so you give me some show me some of the numbers or show me some of those imagination. If we have that much of the lollipop, how heavy it could be? You can think about the object, okay, like a elephant or battleship, okay, aircraft. Okay, what do you think? Okay, show me something.
I guess it's not the point of the earth.
Of course, much bigger. Yeah,
Because it went up the order.
well, much bigger.
Earth.
Earth, not that big. Okay.
Earth.
All the earth.
But I do the calculation is about like 1/10 to 1/5 of the Earth. The mass of the Earth. So it's a being like a planet. It's about not the size of planet, but the mass of the planet. Okay. So you see. So you see the 6.02 times 10 to the 23rd is a really big number, right? Very small things, and then you can expand it. If we have 1 mole of that much, then it's gonna be very big. Okay, then everyone like a donut, right?
I love donuts.
You know the thickness of the donut is about like this, right? Yeah. So if we have 1 mole of the donuts, of course, I mean, we cannot have that much, okay? If we have 1 mole of the donuts and you stack together, how long it could be? Longer.
To
To the sun, longer.
and back 20 times.
And back, okay? So it's about like from here, from Earth to the sun and come back. So it's a pretty long.
Crazy.
Okay, yeah, so that's why, can you imagine this, how big this number it is? It's a really big number, okay? So obviously, we're not using this unit in a real object that we can see, right? We are using those number for the very small object, atoms, molecules, ions, okay? So that is why, okay?
So how do we find this number? It's so huge.
That's great. Okay, how do I find it? Then that's gonna be the next story. Okay. Okay, so how people can find this number? Okay, so and also they have a 6.02, and it looks like it's not a whole number, right? So how do people find this number? to define this number is just a mole. And just to let you know, this is a man-made unit. It's a man-made unit. So how the people can do this? And usually the people count. I mean, this is I don't 100 years ago or even older. So the people defined 12 grams of carbon 12. Okay. So people got the carbon 12 for 12 grams, and they measure how many numbers of the molecules inside. Okay, how many numbers of the atoms inside of the 12 grams of the carbon 12. And then they measure that. How they measure? Generally, they measure the mass. So this is I mean, the number figure out is after they figure out the mass of the atoms. Okay, they figure out what's the mass exactly 12.00000. There's a lot of zeros gram of the carbon 12, and then they figure out what exactly the carbon 12, what is the mass of carbon 12, and then they calculate how many molecules or how many atoms exactly inside of that. This is the number 6.02 times 10 to the 23rd. Okay, so this is how people define 1 mole, because 12 grams of the 12 carbon 12 have that much numbers of the atoms inside. So they just define this is a 1 mole of this. So they said 1 mole of carbon 12 is equal to 12 grams. This is how they define that. Okay, 1 mole of the carbon 12 equal to 12 grams. Okay, yeah. So then this gives you a very good opportunity. Okay, so that is why we can based on this to convert the mass in atom to the mass of another unit. Is called the molar mass. Okay, to the unit of the molar mass, because 12 carbon 12, and we know it's about like 1 of the carbon 12 is about like a 12 AMU, right? But the point is, I don't know the AMU. Okay, we're not using the unit. This unit is too small. Okay, so what are we gonna do? We want to know some of the units that we use daily, like a gram, right? We can using the balance to measure gram. So that's why, I mean, if we have some of the units with the gram, then that's much better, right? That's much better. So they define 1 mole of the carbon 12 equal to 12 grams, which means the molar mass, the carbon is about 12 grams per 1 mole, right? This is a definition, by definition, right? The carbon 12, the molar mass, and we call this is a molar mass, which is the mass of certain object per 1 mole of that object, right? So the molar mass is 12 grams per mole. Then that's going to be much better. We're now using 12 AMU instead of using 12 grams per mole. That makes sense, right? Okay, so that's why you can, if you're looking at all the red numbers underneath, this is the average atomic mass for the elements, right? And then now you can just add the gram per mole for this number, then you got the molar mass of those elements. Then that's gonna be super cool, okay? Because we don't have to worry about how to convert the numbers. I mean, based on this definition, we're just using the mass of the atom and change the unit to the gram per mole. That's it. That's it. So that's why the people define mole, this concept. Okay, so you can easily to convert this from average atomic mass in AMU to the gram per mole, which is molar mass. Any questions? Are you clear? Okay, yeah, so this is why we're using the molar mass in this way. Okay, we're using the molar mass in this way. Okay, so now, if you want to figure out the elements molar mass is pretty straightforward. Just looking at the molar mass over there, that's it. But then we need to figure out what is the molar mass for a whole compound like this, copper SO4. Okay, so this is called copper 2 sulfate, right? You know, this is copper 2 sulfate. And this is, again, this is also one of the substances that we are going to use in the next class. So that's why I'm going to talk about here in the lab. So copper, this is a copper 2 sulfate. And you want to figure out what is the molar mass of this, then you just need to look at, in this formula, how many numbers of the copper. We have 1 copper, and plus 1 of the sulfur, and plus 4 of the oxygen. So you're gonna have a 4 times the oxygen. And then you just need to add the molar mass for each of the elements there, then you can figure out what is the molar mass. So for the whole compound, the copper shows that there is 63.546. And a plus sulfur 32.066. And plus oxygen is 4 times 15.9994. So those are the mass, and then you put them together into the calculator.
159.
Great. Say it again. 159.5196. Okay, thank you. So that is in gram per mole. Then this is the molar mass of this copper sulfate, copper 2 sulfate. Okay, then we got the molar mass of the copper sulfate. And again, the meaning is this substance, if we have 1 mole of this substance, we got 159.15196 gram. Okay, so this is the meaning of that. Okay, and if we have some other molecules like this, you probably never see this before, but you will see it. Okay, so this is also one of the chemicals. This is called we give it a name. This is called copper 2 sulfate, and there's a dot over here. Okay, don't have to write any dot. Then 5 here, there's a pentahydrate. Okay, the pentahydrate. Remember penta, right? So this is a copper 2 sulfate pentahydrate, and this is one kind of the group of the compound. It's called the hydrate. I'm talking about this because we're going to use this for the lab. So it just, and also we're learning this, the molar mass, which is using this. This is called a hydrate. Some of the other compound could be like this. So this is also, those are all hydrate, okay? Which means they have the waters, and they combine the water with it. The dot over here is not a multiplication sign, okay? It's not a multiplication sign. The dot in the chemical formula, it just shows this kind of the water molecules actually is combined inside of the water, combined inside of the crystals. In another word, this guy is still a crystal. It's not a liquid. Okay, it's not a liquid. The water is actually adding inside of the crystals, make it a crystal. In another word, and this is why we call this a hydrate. Right? Hydrate, that's water, right? Hydrate. And there's another one, it's called the anhydrous. The anhydrous is something that without the water. So generally, hydrate and hydrous, those two are coupled together. If we have a water, this guy can attach the water, then we call this is hydrate. When the water is removed out, when we call this is anhydrate, anhydrous. Are you clear? Okay, so the same thing for this FeSO4, and if we have sodium to SO4. And just to let you know, those anhydrous usually is a powder. It's not a crystal. It's not very good. It's not good looking. But once you combine the water there, there are very beautiful crystals. Okay, they are very beautiful crystals. I can show you some of the examples. Crystal. Yeah, so those are blue color, very beautiful crystal. You see, there's a brilliant. But if you're just looking at the anhydrous, actually, if you see the anhydrous, actually is a white color and just a powder. But if you're adding water there, then they're going to become this. Okay, yeah. So this is quite different. Anhydrous usually is a powder. And if you're looking at some of the others, FeSO4, they probably can, it's the same thing. This is the blue color. Again, this green color is iron 3, iron 2 sulfate hydrate. Okay, this is called the heptahydrate. But if you move out the water, then it's just the powder. Okay, so those are two different. Okay, so now do you understand the concept between the hydrate and the anhydrous, right? Yeah. Okay, now we're still going to practice the calculate the molar mass. Go ahead, work on the molar mass of this. And again, the molar mass over here is not multiply the molar mass of the water multiply molar mass of this. Okay, to solve this problem, it's just molar mass of the copper 2 sulfate. We already got is 159.5196. This is the molar mass of that. And then what you're going to do, you're going to add 5 of this. Again, this is a 5 times water molecule, which means we have 5 water molecules of there, not 5 of the hydrogen 2, only 1 oxygen. It's a 5 of the whole thing. Okay, so 5 times this, which means it gotta have 5 times hydrogen 1.008 times 2 plus oxygen 15.9994. Do you understand what I'm talking about? Okay, and then you can figure out what is the mass. 159.5196 plus 5 times parenthesis 1.008 times 2 plus 15.9994. And we got this 249.5966. And this is in gram per mole. Remember, when you write the molar mass, you're gonna have a unit after that, okay? The number means something. So this is the gram per mole. And then this is the molar mass of this compound, right? Okay, go ahead to calculate the molar mass of this. And you're going to doing this anyway in the lab. So why not just going to do it, working on the molar mass of those two, okay? Yeah. you can look at your periodic table to figure out what exactly the mass.
Well, so the problem I had with like the oxygen, for example.
That's okay. If it's round like this, then you use that. Okay.
Oh, okay, because it shouldn't make that much difference.
Yeah, it won't change too much. Okay. Yeah. And by the way, in the future, when we do the exam, if it's talking about the molar mass, I mean, it should be given for the molar mass, except the question is asking for the molar mass. Okay, so now, what is the molar mass of this? Again, you have the iron, one of the iron, and one of the sulfur plus 4 of the oxygen. And then you plus 7 times of the water, right? Which is 2 of the hydrogen plus 1 of the oxygen. Okay, so now you replace this with the molar mass of each of those elements, then you will figure out what is the mass. Right? Okay, so this is the molar mass again. I'm not going to show the numbers because in your lab you're supposed to work on this on your own and figure out the molar mass. Sodium sulfate with the 10 of the water is doing the same thing. And this is called the sodium sulfate decahydrate. Okay, decahydrate. All right. So now this is what we talk about the molar mass, right? We talk about molar mass. I think we're done here. Okay. Yeah, I'm not going to talk too more. The following parts is a lot. It's too much. Okay. Yeah. So I'm done over here, and we will come back on Thursday to finish the rest of those.
Like, it's an estimate.
The text will be graded. I mean, before the class, before the next class.
Okay.
Mhm.